Good morning.
Good morning.
All right, there we go. Okay. All right, so I've been asked to talk to you today about how RDA might be used in the future, specifically as it relates to the emerging semantic web. So in this presentation, I've taken the approach of how using RDA with the semantic web will help solve some of the challenges we face today and how the semantic web may impact the future of music cataloging. Certainly, one of the biggest challenges cataloging faces is economic. Technical services departments have been asked to do more with less. While one can certainly argue about the underlying causes of this situation, the reality nevertheless remains. Technical services departments, at best, will maintain current levels of staffing, but more likely than not, will have to deal with dwindling resources as time goes on. On the other hand, the numbers of materials needing access has continued to grow and are coming from more and more disparate sources. Many of the materials that music libraries buy are no longer just coming from large publishing houses and sound recording labels. They are increasingly coming from small independent publishers and niche sound recording labels. While I certainly feel that this is a good thing for the discipline, it has not been accompanied by declining purchases from established publishers and labels. If anything, the level of materials coming from established houses has remained the same, while purchases from smaller publishers and labels have increased. This has led to large cataloging backlogs at many music libraries. Finally, many music libraries contain and continue to receive discrete collections of materials which are perceived as bringing added value to a library's collection. Unfortunately, many of these collections have not been exposed to a wider audience, many times due to the perceived difficulty of providing access to such collections, and an emphasis placed on cataloging traditional materials by music catalogers. We are therefore presented with a real problem: stagnant or declining resources for cataloging staffs, which are also expected to provide access to more and more materials. Perhaps even more ominous for cataloging are the behaviors of the users we are supposed to be serving. As has been shown in the Calhoun report to the Library of Congress in 2006, and in the report entitled On the Record in 2008 from the Library of Congress Working Group on the Future of Bibliographic Control, the library catalog is no longer the first online resource which users consult when seeking information. More often than not, users start at the Google search bar or by consulting other online resources first. Now, libraries have reacted to this development in a number of different ways. Some have sought to make the OPAC interface more web-like by layering on a discovery interface, something like Opera Browser. Other libraries have sought to integrate third-party databases into their catalogs by using WorldCat Local, so that the local library catalog and the databases to which the library subscribes are no longer standalone products that require multiple searches in each. However, these approaches all suffer from the same defect, namely that users must come to the library portal first in order to access this information. Now, perhaps a better approach, suggested by many in the library community, would be to meet our users where they already are, on the web at that Google search bar. Now, if this is our future, and based on the evidence, there is no compelling reason that this is not the case, then it is incumbent upon us to find solutions which make the data we produce as catalogers as web-friendly as possible. But we also want that data to be easily searched, processed, and manipulated by machines. Now, one possible way of doing this is by producing data that is in line with the principles of the semantic web. Its premise is that in order for machines to make sense of data, it must be simplified to statements that describe one and only one idea. As more of these atomic statements become available, the computer can then start to make associations among all these data statements. So take, for example, this sentence. Damian Iseminger, a librarian at the New England Conservatory, was born in Lafayette, Indiana on March 7th. Now, in order for this statement, which seems simple to us, to be understood on the semantic web, we have to break it down into its constituent parts. So, I have a job as librarian. Damian Iseminger is employed by New England Conservatory. Damian Iseminger was born on March 7th. Damian Iseminger was born in Lafayette, and Lafayette is a city in Indiana. Now, in semantic web terminology, these atomic statements are called triples, since they consist of three parts: the subject, or what the triple is about; a predicate, also known as a property, which defines one and only one relationship; and an object. The triple is the basis of the data model known as the Resource Description Framework, or RDF, which is itself the bedrock of the semantic web. In RDF, in order to make this information machine actionable, both the subject and the predicate must be represented by some sort of unique machine-readable identifier, known as a Uniform Resource Identifier, or URI. Since we want our data to be of the web, a natural choice for a URI would be one in the form of a URL. The object of the statement of a RDF statement may be either a natural language, which is known as a literal, or a URI itself. So let's look at the single statement Damian Iseminger is employed by New England Conservatory. So to make this machine actionable, we're going to assign a URI to represent the person Damian Iseminger, say, for example, this. We're also going to assign a URI to the property, say something like this. So we now have a statement that can be acted on by machines. This URI has as a property this URI, and the literal is New England Conservatory. So basically what this is saying, if you were to translate it to English, Damian Iseminger is employed by New England Conservatory. But we have to dumb it down for machines because machines are dumb. Machines, at least machines at libraries, are going to be using what the web is using. There's no reasoning on the web. But we have this triple here. Couldn't we also make RDF statements about the entity New England Conservatory? These could be statements about the location of the conservatory, the year it was founded, enrollment for a particular year, or faculty and staff members that work there. What makes the idea of the semantic web powerful is that the object of an RDF statement can also be the subject of another RDF statement. So in order to do this, we would also need to assign a URI to New England Conservatory. Say something like that. Then the RDF statement would now look like what is seen here. It's nothing but URIs. And then what we can say, and then an RDF statement that asserted the conservatory was founded in 1867 would then look like. So the New England Conservatory that was an object here is now a subject. We have a property that it was established, and then a literal of 1867. So these same principles about RDF can be applied to the other statements I made about myself earlier. But let's get back to the present. While the semantic web may seem new, the concepts that undergird it are nothing new to catalogers. A bibliographic record is nothing more than a series of statements about a bibliographic unit. The Ferber conceptual model for bibliographic data has at its heart that bibliographic entities exist in a series of relationships with one another. The attributes that describe the Ferber entities themselves could be reconceptualized as relationships as well. So a work has a title X. A work has a medium of performance Y. A work has number Z, and so on and so forth. The concept of assigning identifiers is also familiar to librarians. All bibliographic records have some sort of local database identifier in addition to some other global identifier, such as an OCLC number or LCCN. Authority records for persons, corporate bodies, and works also have identifiers. Now, while these identifiers are meant to identify a particular record, we can extend this concept to represent real-world objects, what is behind the authority record. So what we as catalogers need to do is to take these familiar concepts and apply them in a much more rigorous and systematic way so that users on the web can take full advantage of the data we produce, and so that our data can be integrated with other available data on the web. The new standard for description, RDA, while not originally developed for use with the semantic web, nonetheless follows some of the principles of it by more clearly defining and discretely identifying the individual elements of a bibliographic description. In fact, much work has already been done to convert the instructions and vocabularies of RDA into something that can potentially be used on the semantic web, something I will get into a bit later. Now, I realize that much of what I'm saying about the semantic web sounds sort of pie in the sky, but in point of fact, much of the architecture for taking advantage of the semantic web already exists. So this graphic, known as the semantic web stack, shows all the technologies needed to fully implement the semantic web, and each layer builds on the other. The technology already exists and is in use for those parts of the stack within the red box. Now, time doesn't permit me to go in depth about each part of this stack, but hopefully a brief explanation of those elements within the red box will suffice. Now, we should all be familiar with the Unicode character set, so I don't need to offer an explanation here. Identifiers, a URI, is what is used to identify a specific person, a place, a concept, just about anything. Now, this URI has to be unique and persistent. That is, the URI string will never be changed, and the URI string will exist in perpetuity. The syntax portion of this stack is how the RDF data model is encoded, and is the way in which RDF triples can be exchanged between systems. XML is one of the syntaxes commonly used to express RDF. A good analogy here is the Z39.2 standard, which we all know as the MARC communications format. The taxonomies and ontologies are how we define the relationships within between vocabularies and properties on the semantic web. Think of a vocabulary as something like the Library of Congress subject headings. A property is somewhat analogous to the labels we give to different parts of a bibliographic description. For example, we have titles, edition statements, publishers, etc. A better way of thinking of a property is that it defines a relationship. So in our world, a resource has a title, which is Y. A resource has a publisher, which is X. Finally, Sparkle here is the language used to query or search the semantic web. Now, as I mentioned earlier, work has already been done with RDA to define the vocabularies and properties it contains so that it can be used on the semantic web. This work here has been done by the Dublin Core Metadata Initiative, RDA Task Force, and the fruits of the labor can be seen at the Open Metadata Registry, the URL for which is http://rdvocab.info. What the task force has done is gone through the entire text of RDA and identified the properties or elements and the vocabularies contained within, and have assigned unique URIs for each vocabulary term and RDA element. Furthermore, they have defined the relationships within each vocabulary and element set using the taxonomic languages of the RDF schema and SCOS. It is possible to create a semantic web-friendly description of a resource using these elements of vocabularies gleaned from RDA. Now, on this slide, I've done a semantic web description of a resource, in this case, a score and part of Elgar's cello concerto. The URIs that you see in red are the subjects of what I'm making statements about, which in this case are about the work, the cello concerto, the expression, the notated music edited by Janos Starker, the manifestation, the physical score itself, and the item in NEC's copy of the score. The items that you see in green are URIs for the properties. This is the second part of our RDF triple. Finally, the statements you see in blue are our objects. These can be either URIs or they can be in natural language. To give you a clearer idea of what's going on here, let's just look at two examples. The first one is going to come from our manifestation. The URI in red is the resource we are talking about. In this case, it is the URI for the resource at worldcat.org. This here, RDA1 title proper, is used and it's being used as a shortcut in RDF XML so that we don't have to type in a long URI all the time. So the RDA1 portion here stands for this thing right here. So if we combine this thing with the thing that says title proper here, you'll have a full URI for our property. And then finally, this is our literal in blue here, the object of our RDF statement. So this is also a machine can read it. So let's take away all the XML. So what we are left with is the RDF triple, this URI, and then this literal. So it still seems a little bit like gobbledygook, but that is so a computer can parse the information. If we translate this to human readable text, this is what we get. This resource has a title proper of Concerto in E minor for violoncello and piano, Opus 85. Now let's look at an example where it is nothing but URIs, this time from the work. Taking away the XML, we are left with this RDF triple. And translated into human, this reads as, this work has as a composer, Edward Elgar. Now, I realize that this may look exceedingly complex to many of you out there, and I want to address your concerns. We are not quite all the way there yet in utilizing the semantic web for resource description. Probably the most important thing that has yet to be realized for the semantic web are the user interfaces and applications. These could be anything, an application that searches the semantic web, or more importantly for us as catalogers, a client that would allow humans to easily create resource descriptions for the semantic web. Right now, it is laborious to hand code a semantic web description for a resource, much more so than a MARC record. Human-friendly interfaces and applications are going to be crucial if we are to realize the full potential of the semantic web. But, for the sake of argument, let's say the hurdles to using the semantic web have been overcome. How can the semantic web help solve the economic challenges, cataloging more and more resources with less money and staff, and the user challenges, the Google first mentality we face right now? First, let me tackle the user challenges. Making our data semantic web compliant means that library data does not have to be in the various silos it currently occupies, and which makes it difficult for our data to interact with data produced outside the library. It means that our data can live, so to speak, out on the web. Our data would essentially be of the web. What this means for users is that library-produced metadata could be embedded in popular websites, such as Wikipedia, through the use of an API that would retrieve semantic web data. Searches on Google could return results that your local library owns the item about which you queried. Just having our data freely available on the web means that someone could come along and do truly novel things with it, things that you and I can't even begin to imagine. But, in the end, it all comes down to money. If the semantic web can't produce a net savings in cataloging resources, it won't be used. Even if having our data be more web-friendly is a boon to our users, it won't matter if the costs for doing this are too high. I believe that moving towards a semantic web model for cataloging can result in significant savings for libraries for the following reasons. Resource description is truly distributed on the semantic web. Since library data would live on the web and not in library databases, there would no longer be any need for each institution to have a copy of a record. If a description of a resource exists on the semantic web, cataloging departments would simply indicate that this resource is owned by their institution by making an RDF statement. No more going to OCLC, adding holdings to the master record, downloading the record into the local system, and then making local edits. The resource descriptions available on the web, however, may not necessarily be descriptions produced by libraries either. Descriptions could be available from publishers, retailers, or even enthusiast communities. I understand that this can feel disconcerting, and it's disconcerting even to me as a cataloger, But we also need to accept the fact that there are other communities out there who may have just as many important things to say about resources as we do. Authority control is also greatly simplified on the semantic web. The emphasis on using URIs to unambiguously identify objects or concepts such as a person or a corporate body, a work or a subject, means that we no longer have to rely on natural language heading strings to identify these objects. These strings can certainly be used as human-readable labels for the object or concept, but the idea of an authorized form of name suddenly becomes obsolete in the context of the semantic web. Right now, in our current environment, every time somebody's name changes on an authority record, we have to go through the file and change the name on every single bibliographic record to the new form. If a URI was used instead to represent that person, we would no longer need to do all these changes. We would simply be changing how the label for the URI is displayed, but not the actual URI. Now, it is certainly important to users that all forms of name in various languages are identified and recorded to facilitate searching, but it is no longer necessary to state that one form of name should be preferred over the others. An excellent example of this is the Virtual International Authority File project. The VIAF project gathers all the heading forms of persons and corporate bodies from catalogs all over the world and lumps them together in one record. So using Beethoven as an example, Beethoven in this VIAF record is identified by the URI in the red box here. His forms of names from several National Library authority files are listed below. The idea is that a semantic web application could use the URI for Beethoven, but could display in a human-readable interface the form of name that would be preferred by the user. But since URIs can represent real-world objects, such as persons or works, we can also say things about these real-world objects using semantic web principles. By removing the onerous task of forming headings and performing bibliographic file maintenance when a heading changes, this frees up time for using our music knowledge to contribute to the semantic web. As we know, not everything that can possibly be known is on the web. The web is only as good as the information that is made available to it. For example, this is a screenshot of the DBpedia page for Beethoven's Ninth Symphony from 2011. DBpedia is an attempt to extract structured data from the online resource Wikipedia. As you can see on the slide, the only things DBpedia was able to extract were these 4 properties. Now granted, the information about the Ninth Symphony in Wikipedia itself contains a copious amount of information, but nothing that is structured so that a machine can understand it. We are in a unique position in that we can add to these properties. We can add statements about medium of performance, opus number, key, year of completion, who composed the work, movement names, and so on. What makes us music catalogs important is that we are subject specialists. It's time we put what we know out there. The cost savings realized in more efficient copy cataloging and simplified authority control allows us to provide access to unique or special collections, our most important assets. There are going to be resource descriptions which will not be available on the semantic web, namely those that are unique to individual music libraries. Because of the possible time savings to workflows that moving to the semantic web might provide, we have an opportunity to do something really special with our hidden collections. Instead of them remaining hidden, they can be finally exposed to the world.